Sudden deceleration generates catastrophic kinetic shockwaves. While human brains fail at 100 Gs, the woodpecker survives over 1,000. Striking at 25 impacts per second, this bird defies physics. It does not use external padding, but an internal organic damping engine. To understand this, we must look past the beak to the hyoid apparatus, a specialized bony structure acting like a safety belt. The hyoid bone does not stay in the throat. It splits into two ribbons, wrapping around the skull to anchor between the eyes. As the beak strikes, the hyoid loops flex under the load, routing destructive force away from the brain and across the skull. This is only the first layer of defense. Inside the skull, we find a complex stratified spongy bone matrix. Unlike uniform mammalian bone, the woodpecker's cranium is packed with a porous, plate-like grid that alternates with dense cortical layers. As kinetic shear waves enter this matrix, they hit millions of microscopic density boundaries, forcing the energy to change direction. This process breaks the acoustic wavefront apart, converting mechanical shock into harmless thermal friction within the bone structure. The final piece of the shield is the real-time modification of internal cranial fluid dynamics to prevent brain sloshing. Milliseconds before impact, neck muscles contract to compress the jugular vein, increasing pressure inside the cranial cavity. This creates a hydraulic jacket of blood and cerebrospinal fluid, locking the brain tightly in place against the skull walls. By neutralizing rotational movement, the bird transforms a violent impact into a perfectly controlled, safe deceleration loop. The black woodpecker outperforms modern aerospace damping systems by managing extreme overloads without any material degradation. It proves that the most violent physical constraints are solved not by resisting force, but by mastering the geometry of structural harmony. Through this elegant combination of hyoid tension, spongy bone grids, and hydraulic shielding, the woodpecker remains the sovereign of impact.